Okay, in 3.2, we are doing implicit differentiation, which is just finding the derivative of an implicit equation instead of an explicit equation. So an example of an explicit equation is one where it starts with y equals or f of x equals. So something like y equals 3x to the fifth minus 4x plus 1. It starts with y equals the independent variables on the right, so that's an explicit equation, and we already know how to find the derivative of that very easily. Okay, there are times when it is not easy to solve for y. So if it was something like x squared plus y squared equals 9, it does not start with y. The x's and y's are all mixed up together, and there's not an easy way to separate them, or I could even put them right next to each other. I can make up whatever I want. Okay, these are implicit equations. The y is included within the equation. We still can find the derivative, but we can't use the technique we've been using before. Okay, so these are going to be the steps for doing implicit differentiation. Okay, so I'm going to look at this. This is an implicit equation because I have y's over here, I have y's over here, and there's no easy way to isolate the y, or I might just do that. Okay, I'm still going to take the derivative. But each time the derivative of y is involved, I'm going to include a dy dx, because the derivative of y is dy dx. So let's look at this one right here. So the derivative of y squared is 2y. Since it involved a y, I'm going to also say dy dx. Minus the derivative of negative 5x to the third is negative 15x squared. Equals the derivative of 3y is 3, but because it's involving a y, I'm going to say dy dx. Okay, now step 2. I'm going to gather all the terms with dy dx on the left side, everything else on the right side, because I'm trying to find dy dx. So let's isolate it. Okay, so I'm going to keep the 2y dy dx on the left. I'm going to subtract the 3 dy dx, and I'm going to move the negative 15x squared to the opposite side, so now it'll be positive 15x squared. Okay, now step 3, factor out the dy dx if necessary to create only one dy dx term. Okay, so these both have a dy dx. It's a common factor because I'm isolating it. So dy dx, I'm going to factor it out. If I factor out the dy dx, I'm left with 2y, and I factor this out, minus 3. Okay, now the last step, I'm going to solve for dy dx because that's what I was actually trying to find. So dy dx equals, okay, I'm going to divide by 2y minus 3 and divide by 2y minus 3. So I get 15x to the second over 2y minus 3, and then this is the derivative of y in terms of x. Okay, I'm going to go ahead and do all the steps on the next problem. If you're comfortable, pause the video and then try it on your own. Okay, I'm going to find dy dx. Some people, because it's easier to write, they'll use the notation y prime, because remember, they are synonymous. So I'm going to use that on this one, and then you can decide which one you prefer. You just have to be careful because y prime sometimes starts to look like y with an exponent, so be careful. Okay, let's see. This is an implicit equation because I have y's over here, I have y's over here, and even if I move the y over, it still wouldn't make it that much easier. I wouldn't be able to solve for y. Okay, so I'm going to do the derivative of y with respect to x. Okay, so let me find the derivative of y to the third. Derivative of y to the third is 3y to the second. Since it's involving y, I'm going to do dy dx, or I can do y prime. Okay, now the derivative of 2x is negative 2 equals the derivative of x to the fourth is 4x to the third, and the derivative of 2y is 2, and then I'm going to do dy dx, or I'm going to do y prime. Okay, next I'm going to move all the y prime terms to the left and the other terms to the right, or it doesn't matter which side as long as they're isolated. Okay, so 3y squared y prime is good here. I'm going to minus the 2y prime over here. Okay, now on the right side I have the 4x to the third, and then I'm going to add the 2 over to this side. Okay, now I'm trying to isolate the y prime. So I'm going to factor the y prime out. Y prime, 3y to the second minus 2 equals 4x to the third plus 2. Okay, and then I'm going to divide by 3y squared minus 2. So y prime equals 4x to the third plus 2 over 3y squared minus 2. So dy dx is equal to 4x to the third plus 2 over 3y squared minus 2. Okay, let's look at a more complicated one. Okay, so let's look at this. This is the sine of xy equal to 10x. I can't turn this into an explicit equation. I can't solve for y easily. And I feel like it's going to make it so much worse if I even try. So we're going to just try to find the derivative of this thing as is very carefully because I see some chain rule stuff in here. Okay, so to start off, what do I have? I have the sine of this thing. Okay, so I want to do the sine of this thing. The derivative for the sine of something is cosine of something. So now I have the cosine of that thing. Okay, now the problem is the thing I took the cosine of has a derivative of as well, so now I have to do the derivative of this because the chain rule says do the derivative of the outside, and then do the derivative of the inside. Because this is x times y, I have to use the product rule. Okay, so the derivative of xy. Product rule is going to be x times the derivative of the second thing, I'll call it y prime, plus the second thing times the derivative of the first thing. The first thing is just x. The derivative of x is 1. Equals the derivative of 10x is just 10. Okay, let's look at it again because that was a lot of stuff. Okay, so this was the sine of this. The derivative of sine is cosine of this. But then because of the chain rule, I had to find the derivative of this. This is a product, x times y. So for the product rule, I did the first thing times the derivative of the second thing, plus the second thing times the derivative of the first thing, and the derivative of x was just 1. For the right side, derivative of 10x was just 10. Okay, I need to isolate the y prime. I'm going to go ahead and distribute this, and then I'll isolate it after. So I'm going to have x times y prime times the cosine of xy plus y times the cosine of xy, and this still equals to 10. Okay, let me keep the y prime term on the left, and I'll move everything else to the right. So where is it? This is the only y prime term, so I'll leave that one alone. X, y prime, cosine of xy equals 10, and let me subtract the y cosine xy to the right side. Okay, I'm almost done. I just want to isolate the y prime. So y prime equals that thing. And I'm going to divide it by, what do I want to cancel? I want to cancel the x, and I want to cancel the x cosine xy. X cosine of the xy. So I have the derivative of y with respect to x is equal to 10 minus y cosine of xy divided by x times the cosine of xy. Okay, now let's go ahead and find out when this is actually useful. Okay, so what did they want me to find? They want me to find the equations of the tangent lines to x squared plus y squared equals 4 when x is 1. Okay, I'm not going to solve for y. It's going to give me a plus minus situation. It's going to be kind of ugly. But I am going to try to find the derivative because I want the slope. Should I draw it now? No, we'll draw it now. Okay, if I were to graph x squared plus y squared, that's a circle. The center is 0, the radius is 2. So it's something like this. The radius was 2. So x equals 1 is up here. Oh, it's also down here. So I'm trying to find the equation, or in this case, equations of the tangent line. So I'm trying to find this one and this one. That's what we're going for. I don't really need to know what it looks like to be able to do that, though. Okay, what do I need? For the equation of the tangent line, I need the ordered pair, and I need this slope. Let's get the ordered pair first. Okay, so when x equals 1, I'll get 1 squared plus y squared equals 4 y squared equals 3, y equals plus or minus the square root of 3. So this must be 1 comma square root 3, and this is 1 negative square root 3. Okay, so I have the ordered pair. For the tangent line, now I just need the slope. To find the slope, I need the derivative. And because this equation is not solved, I'm going to use implicit differentiation. Okay, so let's look at this. The derivative of x squared is 2x plus. The derivative of y squared is 2y dy dx, or y prime. The derivative of 4 is 0, because it's constant. Okay, let me go ahead and move some stuff around. That's going to be negative 2x. So if I want dy dx, I get negative 2x over 2y, which is, the 2's cancel. So negative x over y is the equation for the derivative, which is also the equation to help me get the slope. Okay, now let me find the slope. No, I should have left more space. I'll put it over here. Okay, now there's 2 equations. So what was my first one? So at 1 comma, let's do positive square root 3 first. What is the slope going to be? M is going to equal negative x over y. So that's going to be negative 1 over root 3. Negative x over y. Fair? Okay, so that means my equation of the tangent line is going to be y minus root 3 equals negative 1 over root 3 x minus 1. That's one of my equations. Okay, now let's consider the other one. What's the other one? At 1 comma negative root 3, my slope is going to be negative x over y. So negative 1 over negative root 3, which is just 1 over root 3. So the equation of my tangent line will be y plus root 3 equals 1 over root 3 x minus 1, and then that's my second tangent line. Okay, we'll do one more application using implicit differentiation. Okay, horizontal tangent line. If it's a horizontal line, the slope is 0, so dy dx is going to be 0. If it's a vertical tangent line, the slope is undefined, so dy dx will not exist. Okay, so when would that be useful to us? So let's look at example 3. For example 3, it says find all horizontal tangent lines of the graph 3x squared plus 2y squared equals 16. If it's horizontal tangent, remember I want the slope to equal 0. Okay, so I'm going to go ahead and find the derivative, and then I will set it equal to 0. And then see, should we graph it? I don't know, we'll see. Okay, the derivative of 3x squared is 6x plus 2y, 4y. And since it has to do with y, I'm going to use dy dx or y prime. Derivative of 16 is 0. Okay, let me solve this. 4y, y prime equals negative 6x. Y prime equals negative 6x over 4y. Let me simplify that. Negative 3x over 2y. Okay, now what am I trying to do? Since this is a horizontal tangent, I want this to equal to 0. Okay, let's solve this. Okay, if I multiply by 2y, they cancel, so I get negative 3x equals 0, which means at x equals 0, there is a horizontal tangent. Okay, let's figure out what the y value is there, because a horizontal line should be y equals. Okay, let me plug it in. 3 times 0 squared plus 2y squared equals 16. 3 times 0 squared is nothing, so 2y squared equals 16. Y squared equals 8. So y is plus or minus root 8, which we're going to simplify because we always simplify. So y equals plus or minus 2 root 2. Okay, Okay, let me check. Did we answer the question? They want the horizontal tangent line. Since it's a horizontal line, it has to be y equals. So I found the y equals line, and there was actually 2 of them. One at 2 root 2 and one at negative 2 root 2. This graph's actually an ellipse. So if you graph the ellipse, there should be 2 horizontal tangent lines at those values. Okay, last one. Oh, it's the same ellipse. We want to find the vertical tangent lines of the graph. Okay, but I already found the derivative. It's the same. So what was it? It was y prime equals negative 3x over 2y. Let's see. For this to be undefined, I want the denominator to equal to 0. Because if I do something divided by 0, I'm going to get an undefined slope. So if 2y equals 0, then this is going to be y equals 0. What am I trying to find? I'm trying to find vertical tangent lines. I know they occur at y equals 0, but if it's a vertical line, then it must be x equals, because that's what vertical lines look like. So I do have to plug this in. Okay, so 3x squared plus 0 equals 16. X squared equals 16 over 3. X equals plus or minus 4 over root 3. And I think I'll leave it like that. I don't have a problem with that. Okay, so these are vertical tangent lines, so they say x equals, and they occur when the denominator equals 0, which made the tangent line undefined. I think we're good.